Well, good morning, audience. I'm here with Bill D'Agostino, VP of Sales and Marketing at Hog, and we're here to talk all things epoxy. And we're going to cover a variety of subjects, but basically I'm going to be explaining for Bill. Bill's been on the material side for a very long time, and now moving towards understanding equipment. And so you're going to hear me, Bill, talking about differences between our equipment and some of the other competitive equipment in the industry.
Great, looking forward to it.
So, first thing I want to do is I have some video of apparatus that I think you're going to recognize, and whether it's from MRL or Aero or Endosys, I'm not really sure. I think it may be MRL, but Anthony is running the switcher for us. Anthony, let's just jump right in. We're going to cover this subject matter and not necessarily in any particular order. In the end, all of these systems kind of function together anyways, and we'll give you a flavor. So stop right there, Anthony. Just kind of halt right there. So Bill, what we've got here, I'm going to use my laser pointer, but this is a hydraulic piston that moves the material pistons down below up and down.
Okay.
And this is a sensor that senses the position of this. When it gets here, it trips a hydraulic valve. That hydraulic valve sends the fluid back to the other port and sends this down, and thus this is going up and down from here to here. Go ahead and roll the video, Anthony. And then, you know, this is one of the biggest points of contention, that I find a lot of flaws in this this is quite a cluster. If you look at how difficult it is, let's just say that here's your packing nut in here, and let's say that, you need to tighten that packing or you need to change it. Can you imagine how difficult it is to get a wrench in between all of these pistons to be able to maintenance or adjust the tension on that packing? I mean, it's really next to impossible. So another thing I'll point out about this is actually a 3-color truck, and rather than putting a whole nother pumping system on, you can see that they have 5 pump legs here. 1, 2, 3, 4, 5. Now this middle piston will be pumping catalyst. It's a 2-to-1 truck, so the middle is sucking and dispensing catalyst. And then 2 of these legs are yellow and 2 of them are black. So if you wanted to do black instead of yellow today, you must then uncouple 2 of these pump legs and couple the other 2, whichever color you want, in order to dispense the material. Go ahead and roll the video. On our truck, we take a whole nother approach, and I think we've got some B-roll for you that'll be edited in that shows we just have a separate pump for each color. And we don't have any kind of complicated, in fact, if you just kind of look over this way, I actually have here on the stage here with me, this doesn't have any sensors, Bill. It just has an air motor, and it's just going round and round and round and round. There's nothing that needs to tell it to go back in the other direction. And rather than having all these pump legs that are clustered together like this, we mount our pump legs in line. And so to access, you can just see how incredibly different the access is. And you can see here how the pump legs are actually at sort of chest height for very, very easy accessibility. If you do have to do any maintenance, when you have to do maintenance, all these things require maintenance.
Right.
Then you're able to access them easily, and you can see that so clearly in this B-roll.
Okay.
So going back to...
and it's nice, it's all enclosed too.
Yeah, the top end of that is all enclosed.
Not worried about sensors being clogged or rope. Yeah.
Now, also there is a lot of lines going to and from, and you can see how clustered up this gets. And if you look at the Hog design by contrast, we actually use the platform legs as a manifold. Okay, so these, Bill, for the layman that may not spend a lot of time, these are bleed lines that bleed your packings. Packings will leak over time, and these are just the bleed lines that are bleeding into this bucket to try to avoid this sort of mess here. Now, you know, all these issues are kind of intertwangled, and so I want to just kind of break and show you kind of how our competitors have these very tall tanks. And these tall tanks are, you know, where the material is. And then the particular truck that we're looking at today, it has like this big tall enclosure, and in this enclosure there's a heat exchanger, and glycol comes in the top of this heat exchanger and feeds out. I think it's like a 3/4 copper line, something like this, and the hot glycol goes in there, and then when you fill the tank with material, of course it starts full, but then it of course comes down as you use it and when it gets empty. But this auger here pulls material up and it spills into a tray, and there's like this external sort of chute that even when the tank is empty, this compartment stays full. And the reason it does is because the competitor systems are gravity fed. They don't have a pump pumping material out of the tank and feeding the high pressure pump. So go back to that last image you just left where it's kind of showing the bottom of that clustered up hoses and all. So the competitors have to put these pumps as low. Here's your intake right here, okay? So they have to put these things down here as low as they can go, right? Because they're counting on gravity feeding these things.
Exactly.
So they put the pump legs all the way down here and all clustered up, and they put them as close to the tank as possible, okay? Which just does more to make the space very confined. You see how tight it is. This is your material tanks right here. Here's your material tank there, there's your material tank there, presumably catalyst in yellow, obviously yellow. But what we do by contrast is our tank, we'll just kind of draw our tank down here. And our tank, we have a pump right here. I'm just gonna put a P there for pump, a material pump. It's our hog pump. We manufacture it in-house. It's lightweight, it's fairly inexpensive, it's pretty much maintenance free. And this pump pumps by pressure to the material pump. So you could put the material pumps on the roof if you wanted to, you know, and that's how we get by with putting our high pressure pumps way up in the air. I'm just gonna put, you know, high pressure for high pressure pump.
Yeah.
And that way, that's how you see them sort of at that chest level, is we really don't care where we put them. So it just greatly impacts the accessibility of the pumps, and you're not working with this clustered up bunch of hoses. And of course, the using the platform as the manifold that you'll, you know, it really just, it gets those hoses. We have kind of this pump platform here, and we use these legs as manifold, and then these pump legs here, we just have these little short hoses running right to there. So it's very open, very airy, very roomy, and again, I won't beat it up, but accessible.
Clean.
You know. Yeah. So let's go ahead and roll the tape, Anthony. I think that might be the end of that one. I don't like the idea of having to switch to pump yellow and black, switching all those legs around. That's a lot of work. We just have that third color is right there, ready to go. There you go. Stop there for a second. This is on top of the material tanks, Bill. And you know, I took this video, and I mean, this is an older truck, to be fair. We're not trying to beat up on the competitors by showing old rusty. No, it's an old truck. In fact, kudos to them, because this truck's probably been in service for 15 years, you know. But we're just trying to show you what we think is a better way. This is a hydraulic mixer motor, white catalyst, yellow, and there's a black somewhere. But this is a lot of apparatus. This is your glycol coming in, glycol going out. This is, these things here are like pressure relief valves, I think, for incoming material. This is your material returns. But inside the hog tank, by contrast, there are no moving parts. So, you know, gravity fed on this side. Lots of moving parts inside the material tanks. And inside the hog tanks, you can see here, there are no moving parts. We recirc our material at such a fast rate of speed. How? Well, I'm glad you asked, Bill. But, you know, these material pumps, they pump at very low gallons per minute, maybe a maximum of 6 or 8 gallons per minute per leg. Well, this material pump here can pump 15, 20 gallons a minute. It pumps at a high rate of speed. So you're never, in fact, this is actually, again, these things are all intertwined, but the competitors, they use material pumps to recirculate / heat, and augers to mix, and they gravity feed, right? How do we move the material in order to heat? Because especially in cold weather, the material comes in, it's very cold, you have to heat it. We heat it through pushing it through or around a heat exchanger. So in the hog system, there's simply a heat exchanger here. It's filled with about 120 5/8 inch tubes. The material comes out of this pump, the hog pump, goes up through and spills down in this trough. When it runs down this trough, it runs here and creates this swirling action. Goes out to the pump, and it just keeps doing that the whole time it's warming the material. Typically on a cold day, it might take you 30, 40 minutes to warm your material. How does the other side do that? Again, great question, Bill. You're asking a lot of great questions. And I'm glad you just stop me. If you don't understand something, stop me. But remember, they gravity feed these high pressure pumps, right? And they're using the high pressure pumps to recirculate the material. MRL, Endosys, Aero, they all do the same thing. Now, as this material comes out of here into the material pump, then it goes all the way down to the guns, back up through. There's these things, they call them swage lock valves or Whitey valves, whatever brand it might happen to use, but it goes through a valve, and then it goes back into this tank. Up top, you saw the returns right there, right there, okay? All the way down through the guns, right? So, of course, anytime you start going down through here, there can be a lot of heat loss, okay? So what do? They glycol jacket all of these lines. Oh yeah, glycol jacket. It's another huge advantage that I believe you'll agree with me when you understand it. Glycol jacket on a hog? No, we don't have any glycol jackets.
Does it add weight?
Adds a lot of weight, and it adds to a very clustered up carriage. I think Anthony has some video of the clustered up hoses on the carriage where you can see. So here we go, okay? Here's the glycol jacket around this line. There has to be an in and an out to every high pressure line, every single one, okay? And of course you have a white and a yellow, a yellow and a catalyst on every gun,
exactly,
or a white and a catalyst on the other side of the truck, okay? This is probably a black and catalyst, okay? But you can see what a tremendous number of glycol lines there are, okay? So how does a hog truck work by contrast? Well, we certainly have, coming off the high pressure pumps, we go down here to our guns as well. and we come back and we have a valve and we send it back into the tank, okay? But during the heating process, we don't ever use the high pressure pump to recirculate our material. It's one of the biggest, it's one of the big differences in a hog truck.
Okay.
I'm told by industry folks that I made a whole swing around the Northeast where they use a lot of epoxy, and I ask, hey, Mr. Contractor, what percentage of the time your high pressure pumps are running? Are they spraying material to the road, and what percentage of the time are they being used to recirculate material? On average, Bill, the number I got was 70%.
Recirculating.
70% recirculating, 30% to the road. By contrast, I would say that 80% of the time we're running, our material pumps are pumping material to the road. So how are we heating? Well, we have that hog pump that we talked about earlier. That we use them as load pumps and we use them as recirculation pumps. And when you're loading, there's a three-way valve right here. I'm just gonna put the number 3 right there because right on the outbound side of the tank, there's a three-way valve. When you exercise the three-way valve, the material pump is now sucking out of your tote and it's coming back into this heat exchanger up through, and you're loading. From the tote into the pump, loading. And while it's loading, it's also heating, right? Because it gets one pass through the heat exchanger before it goes in the tank. When you're ready to spray, here's where, you know, contractors, when I tell them there's no glycol jacketed lines on the truck, they look at me and like, with a lot of skepticism. And they want to understand, how is that possible? This is very, very important and a detail that may take a little bit of time to understand.
Okay.
So this valve right here, remember that's a V for valve, right? If this valve is open and you're recirculating to heat, you're going through your whole heating cycle and it's 40, 50, 60 minutes, whatever it is, right? You're heating, right? This valve is open. But when it comes time to spray, an MRL or Aero system has here a three-way valve. I'm gonna put a big 3 here, and I'm gonna put a big 2 here. Our valve is either open with a 1/2-inch hole, or it's closed with no hole, forcing the material to go out the gun, of course, right? Open or closed. This three-way is open or closed. I'm gonna put an O, a C, and then I'm gonna put this little needle here. They have a third valve, and when you turn it to that position, that little opening, that little nozzle is the same size nozzle as in the gun. Why is that? Well, when they go to spray, when they're recirculating, they have their hydraulic pressure turned way down. When they go to spray, they have to turn that hydraulic pressure up because they want their 2,500 PSI material pressure, right? Makes sense?
Yep.
So they get good atomization at the nozzle. If they were to open this up and recirculate, because maybe they stopped at a red light for 2 or 3 minutes or 5 minutes, if they were to open that up, that hydraulic pump would just slap out of control, just boom, 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 and destroy itself, right?
Wow, okay.
So they put a nozzle in there so that whether they're spraying to the road or they happen to stop and put it into recirc, that pump will maintain that same slow speed and maintain that same pressure, right? By contrast, if all you're doing is recircing, why do you need a lot of pressure? I mean, if I were giving them a tip, I would say, hey guys, why don't you have a hydraulic valve that pressure reduces when you go in the recirc, get rid of this nozzle, and instead control your hydraulic system so that in recirc, you drop the hydraulic pressure from 2,500 PSI down to 500 PSI so that your pump just sits there and lazily goes through a 1/2-inch opening the same way as ours. But what we do on ours, our air motor is a 30-to-1 air motor. So theoretically, if you put 100 PSI air to it, and that's why it's so big on top, is it's 30 to 1. So if you put 100 PSI air, it's gonna dispense 3,000 PSI material, okay? We're running more like 2,300 is about our sweet spot. So we have a valve that when you throw it in the recirc and you open this hole, it drops that air pressure down from 80 PSI down to 30 PSI. And we're recircing that material through this 1/2-inch hole. So what happens? We're running at low speed, but fantastic volume. So we sit there and for our 30-minute heat up cycle, we're just using the hog pump, you remember?
Yes.
We're not using a high pressure pump. And then when we're ready to spray, on a 24 degree in Pennsylvania recently, we threw it into recirc. Within 5 minutes, that material is moving through so fast, 1/2-inch hole, remember, open or closed. And within 5 minutes, our pump legs were hot, all the material lines were hot, and that pump is just sitting there very relaxed, going up and down, not at high pressure. When you're ready to spray, boom, close your valve, let your pressure build, and then start spraying. And I think Anthony has a picture of the truck going down the road spraying some lines here on that same, that's me taking that video. I remember it was a cold November day last year.
It definitely gets cold in the Northeast.
And then of course, then while you're spraying, even on a skip line, those lines, there's not enough time in between for those lines to grow cold. Stop right there. So look by contrast, what a clean, no glycol jacketed lines. The other thing you got to understand about a glycol jacketed line, Bill, is that what is the chances from 0 to 100 that a high pressure line will eventually, I'm kind of putting them on a spot here, but what are the chances from 0 to 100 that a high pressure line will eventually blow?
70%?
I said eventually, so it might take a year, it might take 20 years, but what's the chances that a high pressure line is going to eventually blow?
100%.
100%. So if you have glycol jacketed lines, you can imagine the moment the line blows, the material is going back through the circuit, right? You not contaminate your circuit with resin, and eventually with catalyst. Talk about a mess.
It's hard, yeah.
The other thing is that when a line does blow, gang, where did it blow? All you know is you lost pressure. They're glycol jacketed, so it's not like you can see material coming out anywhere. You can see it in your glycol tank, but you literally have to go on a fishing expedition. If it's a white side and there's only one gun and you lost white pressure, well, I guess you know that it's in your white. But is it in the supply? Is it in this pressure side, or is it in the return side? You don't really know.
No.
You got to go fishing. With ours, of course, when you do blow a line, and eventually you will, hopefully it's not a big explosion, it's a small pinhole, but immediately you can see exactly where it's coming from. We do put fire wrap over top, which gives some insulative value, and it does the second thing. If you do blow that line, nobody's going to get shot in the face or the eyes with resin. It's going to drip out the ends here. So it serves as sort of a burst shield, if you will.
Exactly, yeah.
And
nice safety feature.
Yeah, so no glycol jacketed lines, we think is a huge deal. It just leads to a tremendous amount of reduced plumbing apparatus on the truck. All right, hopefully I've made that clear. This system is, they're just showing some bead dispensing. Stop right there a second. Any of you, I'll just bring this over here, Zeke, you don't need to worry, but any of you that have experience with sort of the other guys' bead guns, you know that how prone those glass beads are to getting stuck in threads. So when I decided we would design our own bead gun here, I wanted to design something that has no threads, literally comes apart and goes back together with 3 nozzle selection sizes. I don't know if you can see through there, but that gun is fully apart. Now this one doesn't have a nozzle in it. The nozzles, they're actually right here. We have three different nozzle sizes, small, medium, large. And epoxy takes 25 pounds per gallon. And so it has to, you got to have some different nozzle selections there. Whoop, sorry about that. But I just want to put this back together for you. Just the, so there's no threads for the beads to get caught up in. It's really a wonderful feature. And then the other thing we do, I'm going to hold this nice and still here for just a moment. But, you know, this does look like it's got a little gunk on the right side there, maybe impeding the beads slightly. But we put these striations, these sort of channels in the spoonbill, which promotes, what it does, it promotes the even distribution of beads. If you don't have that, the beads sort of want to tend to go to the outside, and you get real heavy beads on the outside and no beads in the middle. Just put that in there. So, you know, we think that our bead guns are one of the advantages of the hog truck, and we really like the fact that there are no threads on our bead guns. All right, so go ahead and roll that, Anthony. We're just showing here, if you have a worn out nozzle, if you have improper pressure in this spray fan here, you can get a very, it can look sort of stringy. You know, it can look like you got lines in your line. You know what I mean? But here you see a beautiful atomized. Go ahead and finish the roll there, Anthony, and we can move on to the next clip. Yeah, really nice small beads, big beads. All right, bud, let's move on to the next clip. I think we have some other competitive advantage. Well, just, okay, stop right there once. So here you can kind of see the accessibility of the pump legs. You can see that there are no Webasto burners. Our truck has, and I think this probably merits writing down, the heating system of our competitors' trucks. 4 to 6 glycol pumps, and the hog truck has 1 glycol pump. All we do, I don't understand the mentality of these 4 to 6 glycol pumps. We just have a single manifold, and we flood this manifold with a large glycol pump. One of the lines from this manifold goes out to the burner and back to the glycol tank. We have a glycol tank here. So we come out of the glycol tank into the P for pump. Out of the pump, we flood this manifold. And then this manifold has lines that go out to white, yellow, and black, if you have black, and catalyst. And each of those just have a 12-volt ball valve on it. When the material gets up to temperature, we shut the ball valve off. It's extraordinarily simple. And it's very effective at maintaining the temperature.
Okay.
And all this burner does, there's one line that never shuts off, and it goes to the burner and then cycles back to this glycol tank, and it just sits there and runs continuously. And then these ball valves turn on and off to control the individual material temps. And, you know, I think that's another element that a little nuance. I don't think I've ever explained it to anybody here before, but let's see if I can capture this. Because if you have a high pressure pump, and whether you're spraying to the road or you're recirculating, the only way you have to run material past a temperature probe is at a very low speed, spraying speed, right? But by contrast, this hog pump, even when you're rolling down the road and it's supplying material to this high pressure pump, it also has plenty of volume, so it's also recirculating through the heat exchanger. And our temperature probe, we put it right there at that crossroads where it's going out one way back to the tank and it's going out the other way to the high pressure pump. And that continuous flow of material past that temperature sensor provides homogeneous feedback. I don't know what the right word is there, but constant, accurate feedback, so that these ball valves, which are controlled by that temperature probe, the positioning of that temperature probe is very important. If it's positioned well, but there's no material running past it, is it going to read accurately?
No.
You know, so again, all these things kind of work together, and it gets a little deep. But people who spend a lot of time on epoxy trucks, if you're an epoxy striper, there's a Felberg guy out there that I want to see this video, because I want him to understand our truck. But those who have done a lot of striping, they'll understand some of these deeper points that I'm making, and hopefully you're getting a grasp of them too. All right, go back to the 3 Webasto burners. So now these are the competition load pumps, and I think that Endosys, MRL, Aero, I think they're all using these same load pumps, okay? And we make our own hog pumps, and I understand these Granco, these are the brand name, I believe is Granco, and I've heard good things about Granco. I've heard they're a good, reliable pump. They do eventually wear out, but I've heard nothing but good about those, so I won't spend a lot of time. But I don't know why. You have the apparatus for load pumps. Why aren't you using them to pressure feed your high pressure pumps, people? You know, because then you could put the high pressure pumps anywhere you want them and get them in accessible positions, right? But instead, they just have them as load pumps, that's it. Then they just sit there idle the whole time they're spraying and the whole time they're heating. They could be recirculating the material. I feel like maybe I'm helping my competitors now, but I really want, I want to see this industry, Bill, move forward, go forward. Let's make things easier on the men and women that do this work. This is hard work, it's messy work. Let's make it easier on them. Roll the video. So on this truck, there's 3, but it's not uncommon to find 4 Webasto heaters. And these are diesel fired and electric. You see these big heavy number 4 lines, these big fuse blocks. This is heavy wiring, and I think it requires they have a generator on the truck as well in order to feed these things. So, all in my opinion, completely unnecessary. Each one of these burners also has a glycol pump, which is why they have 4 to 6 glycol pumps and 3 to 4 of these heaters. Now, Endosys takes an entirely different approach. Endosys just has this huge generator on the truck, and they heat by electricity. They heat their lines. Go ahead and roll the tape. But just a lot of unnecessary apparatus, plumbing. Stop. Here's glycol lines coming in, because remember, these are heating the glycol. So here comes the in and here comes the out, and they're heating glycol as it comes through here. In our situation, you can see me here pointing to a single glycol pump circulating through a single burner that's actually not in position yet, but will be right in this spot on this truck. I'm gonna remember to point to that, Zeke, so you can see it, and just a simple manifold of these valves, and the job is finished. All right, roll the tape. So this, stop for a second. This is just showing the inside of the material tanks on an Aero or MRL system, and the tank that I was telling you about, where the auger lifts the material up and fills a trough that keeps some head pressure to a gravity-fed pump. Go ahead, roll the tape. Okay, so yeah, let's kind of take a look at this, because I think this is, here at Hogbill, we're always about improving the product. And sometimes a slight configuration change can make such an enormous difference. And whether you look at this truck, and I want Anthony to just go back to the very first picture where you show a sideways image of our truck. So, in some respects, when you look at a sideways picture, they both have material tanks up on top. They both have big bead tanks and an air compressor, and go back to the MRL truck. But neither truck has any space for any totes or any loading of any kind. And we've recently, we're in the process right now, so if you're watching this video a couple of years from now, it won't make any sense, because you'll be like, yeah, that's how they always were. But Anthony, there you go. So what we've done here, Bill, is we've recently, the engineering team has designed lateral tanks. So this is just a material tank here that, instead of being large and tall, is much skinnier, laid within the deck of the truck, which presents some really, really interesting benefits. now you no longer even need load pumps, nor do you need to sit by the road or in a parking lot or at the shop loading your material. In this configuration, the guys have these load pumps. They're right up here, and those load pumps hook up to a tote and suck out of a tote and suck the material into the tank, and really have no ability to heat until the material's in the tank. But now, go back to our lateral design. You can put ice cold totes on the truck, sit them on the truck. There's room for 4 of them, white, yellow, catalyst, black.
Wow.
Okay?
Okay.
And these coils right here, these are copper coils that has an in and an out for glycol. Your glycol lines run up here, come across, go in and out, cycle back to the tank. Each one of them is fed, right?
Yeah.
And they lower into those ice cold pots. You got protection from sun and rain. No epoxy or polyurea truck has a covering over it at the moment, but because now we don't have these super tall tanks in the air, go back to the MRL picture, there's no room for a canopy up here. You wouldn't be able to get, imagine if this canopy was continued. You couldn't even open your lids on your tanks or address a problem with your mixer motors or get in your bead tanks. There's no room. But go back to ours there, our lateral design. You see here, you got plenty of room above here to hang these little things. You lower them, just a little 3/8 rope, little pulley, those things lower down in the tank. Heat the tank. How do you get the material from the tote into the tank? I'm so glad you asked, because there's just going to be a little hose right here. This is the black. This is a short little tank here. And there's a short little hose that goes from there right in the tank. So it's completely sealed. There's nothing open. If it was open, you're going down the road, the air would of course splatter the material everywhere as it's trying to drain. And then these drain into the front and the sides drain into the sides. So white, yellow, black catalyst. The way this picture is shown here, these tanks currently hold 450 gallons. We're just in the final days of finalizing our design. Looks like we're going to end about 350 gallons. We're going to shorten this truck up by about 3 or 4 feet and end up with that about 325 gallons, 6,000 pound bead pots. The hog pumps are going to be right here at the back. Very, very easy to access. Everything's out in the open. Notice the pump legs, as I explained earlier, chest height, very, very open, easy, airy access. And we're really excited about, there's nothing really all that special about lateral tanks. It's just a seamless pipe. By the way, Bill, it's also a lot easier to construct because there's no welding except for just an end cap there, that a flange, so you can bolt your end caps.
That saves a lot of time. Because I've heard, an epoxy or polyurea, when it's cold, it takes a long time to pump it. So they actually sometimes bring a separate truck, a heated truck, to try to keep the temperature. So you're eliminating a lot of prep time here. So
what's really cool, okay, is you load this truck up in the morning, and while you're on the way to the job site, your heating system down here is heating. But what's really cool is once you get to the job site, you can load 4 more totes on your truck. And while you're striping out your load that's in the tanks, the load that's on top of the truck is also heating.
Wow.
Okay?
Makes it so much more efficient.
And that way, at some point, and by the way, if you have a 20-30 minute break, you're waiting on a traffic switch, whatever, you just get up here, turn your valve, and load. There's no you don't have to pull up in a parking lot and have a lot of space for a forklift to start setting totes on the ground beside the truck. The totes are already on the truck. And if they're not on the truck, you can put them on the truck. And while you go 5 or 10 miles down to the next work zone, those tanks are loading in the truck while you're driving. So we think that this small configuration design change is absolutely transformational. Now, by the way, you also need a lot of beads on an epoxy or poly rig. And so 25 pounds a gallon. So if you go back to that picture there, you can also haul beads here. You know, you don't have to haul epoxy. You could haul, you know, if you have a lot of white to do, well, bring 2 totes of white and 2 more totes of beads, whatever you want.
Yeah.
And when you have 5 or 10 minutes, suck beads. The beads are already on the truck. Just hook up your suction line and suck them right in. So anyways, I think, gang, that's really kind of the heart of our advantages. If you open these doors here, we can see our glycol pump, glycol tank right here, glycol pump, 90-gallon black tank right here, and then white catalyst and yellow tanks. Man, I think I'll call it quits for now. There's an aero board, of course, on every truck, not shown there in the back right now. This is your hydraulic cooler, hydraulic tank and cooler. Any questions for me, Bill? Oh, we didn't show our hog tools. Do you have any video of any hog tool system? Because right in this back deck, you can see here how this just is right behind. It kind of keeps you in the safety of the truck. So
that's great.
Another feature at some point that we're going to add here very soon, Bill, is if you've been sitting for 2 or 3 or 4 minutes, it is quite common to have a little, like we call it a little pisser can. And you get out, a guy walks around the side of the truck and puts the pisser can underneath the gun,
right.
And the operator pops it off, and that keeps you from getting rounded starts and gets you a nice crisp start when you go to start again, right?
Yes.
If the material's been sitting for a few minutes, it can happen. Well, we're going to put a tray underneath here, almost like a thermoplastic blow pan, and we're going to make it pivoted in the corner right here, and the guy's going to reach up and pull a ripcord. Now, hopefully, by the time you see this video, it's done, and we're able to get a little video of it so you can see how it works. And that thing will pivot around, and come underneath the gun. The guy pops. When he releases, it spring loads. It retracts right back underneath the deck. And so a guy doesn't have to get off the truck, step potentially into traffic to use the pisser can, okay? All right, with that, we'll conclude our epoxy either training or sales training or marketing training. And we'll conclude with that.
Great.
And hope you found this useful and exciting.
It is very exciting.
So, thank you.
Thank you.